Hello. In my previous video, I was discussed about the fragility curve. Fragility curves, seismic fragility curves, this is the outcome of probabilistic perform-based evaluation of the structure. And the link of that video is given in the description. So that is what is a fragility curve and what are the characteristics of the fragility curve. So please listen that video for the introduction purpose. Again, in my previous video, how to perform incremental dynamic analysis. So that also I was discussed in detail, and the link is also given in the description. Then by using the data from the incremental dynamic analysis IDA curve, in today's video, my focus is how to construct a seismic fragility curve. So as a sample, in the figure, there are three IDA curves, incremental dynamic curves were shown. So this incremental IDA curves, on y-axis, there is a spectral acceleration, which is an intensity measure. And on x-axis, it is interstory drift. And these are the three IDA curves is obtained when three different ground motions were applied with increasing intensity on the structures. Now, about the fragility curve are developed for different damage states. Whenever the building or the structure is subjected to the earthquake of severe earthquake, then it undergoes different damages. Sometimes damage is a minor damage, intermediate damage, and severe damage, it is almost to be collapsed. Now, in several documents, research papers, codes, these damages in the structure uh, have been named with different titles. In one of such document, this is FEMA 356, three damage states were defined. So those damage states are immediate occupancy, life safety, and collapse prevention. These are simply the damages in the structures. And it is also quantified. The immediate occupancy is said to be occur when interstory drift is reaches to 1%. Interstory drift, maximum interstory drift reaches to 1%. Life safety damage state is said to be occur when interstory drift is about 2%, and collapse prevention is said to be occur when interstory drift reaches to 4%. So this is defined in FEMA 356. In other documents, different damage states and with different limits were defined. Now today we will see how to construct a fragility curve for a sample damage state, say life safety. For life safety damage state, we will see how to construct a fragility curve. As there are three damage states, so we can construct the fragility curve, three fragility curves. That is, each curve represents each curve is for a single damage states. Now, to construct a fragility curve, what we required, it is a spectral acceleration value. That is, we will construct a fragility curve which is spectral acceleration based. Why? Because IDA readings are, that is incremental dynamic analysis is done by taking intensity measure as spectral acceleration. So therefore, fragility curves we can develop by taking the spectral acceleration as the basis. That is, spectral acceleration based fragility curve we will develop. According to this limit, life safety, because our focus is to construct a fragility curve for the life safety. So life safety is said to be occur when interstory drift reaches to 2%. So here in the curve, just read the value, that is, this is for example 2%. So for 2% drift, for the first ground motion, what is the value on y-axis? What is the value on y-axis? Okay, so this will be the spectral acceleration value for the first curve. Just extend the curve for the second and just read the value on the y-axis. So this is the spectral acceleration curve, spectral acceleration value for the life safety for the second curve. And for the third curve, it will be this value. Okay, so we will get 3 spectral acceleration values corresponding to interstory drift equals to 2%. If there are 20 number of ground motions, then there will be 20 number of such lines, ideal lines, and we will get 20 numbers of spectral acceleration values. So as an example, we will take a 20 number of ground motions. So these are the first column is a ground motion. Okay, so this is a 20 ground motions were taken, and this is the fragility curve calculation for life safety damage. Life safety damage. So interstory drift will be 2%. So since there are 20 number of ground motions, therefore there will be 20 number of IDA curves. And from each curve, the spectral acceleration value corresponding to 2% drift are these particular values. So these are xi, noted by xi. These are the spectral acceleration value corresponding to drift equal to 2%. You just make a list of this. Okay, after making the list of these things, so these are the reading from the IDA analysis. All these value we obtain from the IDA analysis. Okay, then after entering the value in this column, then arrange this value in ascending order. In the ascending order. That is the first thing. Okay, now this is the equation we are using to construct the fragility curve. Now many researchers were proposed different equations also. Okay, so such one equations we are using for the to construct this fragility curve. Okay, so in this particular equation, what this equation is, P stands for probability. So probability of damage states exceeding the spectral acceleration, exceeding the limit of spectral acceleration is equals to phi. Phi stands for normal distribution. Phi stands for normal distribution into bracket. It is ln, that is natural logarithm of spectral acceleration value. Natural logarithm spectral acceleration value minus lambda divided by beta. This is very interesting. I also explained this in my previous video, link also given in the description. This lambda stands for median of the fragility curve, and beta is a standard deviation. Okay, the slope of the fragility curve represents the variability, and it is expressed in terms of the parameter known as beta. So therefore, if at all to construct a fragility curve, that means we have to find the value of lambda and beta. That's all. We have to find the value of median and standard deviation. Okay, now first of all, we'll say how to find this lambda value, what is called as a median value. Okay, then coming to this calculation. So these particular values, first of all, arrange in the ascending order. Next column is that it is a natural logarithm of this value. Natural logarithm of this value. So these the functions are available, these functions are available in the Excel when we click it. So this is the natural logarithm. Okay, and then similarly, in this column, all the values are natural logarithm of column B. Column B. Okay, then next column is about, then, okay, first of all, we'll see how to find lambda. Okay, then here, this is what? Summation. Summation of column C. This column summation. Okay, and then the mean value or lambda value will be this summation divided by number of readings, that is 20. So minus 19.4292 divided by 20. So we get a lambda value, that is median is minus 0.97146 is the median value of life safety damage state fragility curve, is the lambda value. Okay, now we'll see how to calculate this beta value. Okay, now this is the equation to calculate the standard deviation. It is under root of, in the numerator, summation of ln xi minus lambda, this term square, and whole divided by, in the denominator, n is the number of readings minus 1. Okay, now first of all, this in the numerator term is this. Okay, so this is ln xi, that is this value minus lambda value is this. Okay, and square of this term will be this. Okay, well, then find out summation. Find out the summation of the column D, because here in standard deviation there is a summation. Okay, and then to find, this is the summation, 16 point this thing, then divided by n minus 1, divided by n minus 1, will get this value, and then find out the square root of this. So therefore, after summation, then divided by n minus n is how much? 20 number of readings are there. So 20 minus 1 divided by 19. So summation divided by 19 and square root of this, we get the beta value as 0.93. So this is the beta value. So this such, now thus the two parameters, important parameter for this fragility curve is, this is the lambda value and this is the beta value. Okay, then in this equation, important equation, we have obtained the value of lambda and beta. Then next is very easily we can do the calculation, next calculation for to obtain the probability. Now take another set of readings of spectral acceleration. Okay, not necessary that it should be of this series. Okay, here I have taken the minimum reading at 0.075. Okay, 0.075, then 0.15, then that is with the increment of 0.07, 0.075. With this increment, I have taken a set of spectral acceleration value. Okay, these meaning up to 2.1. I have taken the values as up to 2.1. Then in the this fragility equation, xi, its natural logarithm. So therefore, next column will be whatever these values are there, find out its natural logarithm. Find out its natural logarithm, and then calculate the final column is a probability. Okay, so which is nothing but outside, this is a standard, this is a normal distribution. Now in the Excel, there is a function. there is function what is called as a norms dist. That is a normal distribution here. This function is there. Norms dist. Okay. And into bracket numerical ln value, that is this particular value, this particularly minus lambda value, minus this lambda value divided by beta value. Divided by beta value is this. Okay. And find out its normal distribution. We get probability which is equals to this much for the first reading, right? For the first reading, and then do the similar calculation. So probability for the remaining readings. So this is 0.16, 0.2, this thing, and finally it is 0.96 is there. After that, the reading is 0.96, and maximum probability should be equals to 100%, that is 1. Okay, and then plot a fragility curve, plot a fragility curve such that on the y-axis it is probability, on the y-axis it is probability, and on x-axis spectral acceleration. Okay, because we are constructing fragility curve, that is spectral acceleration based fragility curve. Okay, so therefore that means which are the two columns required to take on y-axis. This is the probability, and x-axis is this column H. Okay, column H, and then we will get the fragility curve like this. So this is a procedure to construct a fragility curve for a life safety damage state. Similarly, we can construct fragility curve for PGA based fragility curve also. But for that, while constructing the IDA, this IDA plot should be such that on the y-axis, it should be a PGA value. It should be PGA value. Okay, so in this way, we can use the IDA analysis reading to construct the fragility curves. Okay, thank you.